Hey guys, welcome 12-2 video coming at you. Let's start out with some vocabulary. We talked about a tangent. A tangent hits a circle one time. Today we're talking about chords. So chords have some fun rules. So if you found the length of a chord, what is a chord? It's a segment whose endpoints are on a circle. Okay? Endpoints on a circle. So actually, a diameter is a special type of chord. And so in the diagram right here, so I draw this picture right here as well, and that definition, that says chord PQ, and its related arc PQ. Let's jump into some vocabulary about this information here. All right. Okay, so here's our first theorem. We have a couple today, so I hope your pencil writing hand is ready, I guess. I don't know. We have a circle, and what's cool is if two chords are congruent, so A, B, and CD, then their corresponding arcs are also congruent, and that also works conversely as well. So we'll get to that, so write that down. Next. Alright, so this is kind of interesting as well. Within a circle or in congruent circles, chords that are equidistant from the center. Remember, the shortest distance from a point to a line would be a perpendicular segment. So that's why we have perpendicular segments right here. So the distance between the center and the chord, if they're equidistant, then I know the chords are the same size. This actually makes sense because as chords get closer to the center, they get closer and closer to becoming the diameter, which is the largest chord in the circle. And as chords move away from the center, they become smaller and smaller, becoming almost one with the circle. Okay, so this works out pretty well. Next. All right, so this one's kind of fun. In a circle, if a diameter is perpendicular to a chord, then it bisects the chord and its arc. So here's a diameter, and it's perpendicular, so that means it's going to bisect that chord and its intercepted arc. Groovy. Again, remember, geometry is all about doing theorems, rules, and applying them. So it's great. Let's go. Next one. All right, in a circle, if a diameter bisects a chord that is not a diameter, then it's perpendicular to the chord. Okay, so AB is a diameter, CD, which is not a diameter, but it's just a chord. We know that if it's perpendicular, then it's going to be, if we know it bisects, then it's going to be perpendicular. So this is basically the converse of the last one that we just did. Okay, all right, let's get to it. Let's get to some problems. I know I have problems in my life, so let's solve them. It's the only thing you can do. Oh, almost got the volume on. I turned it off, don't worry, so we can't hear anything. Here we go. What is the length of RS? Boom. Okay, well, if our distances right here, so check this out, draw this picture, here we go. If this is 9, so boom and boom. We automatically know PR, the chord, and SR are equidistant to the center. Because of that, I know that they are congruent. Okay? So since I got PR right here, I know PR is going to be congruent to SR. My problem is I need to find what PR is. Well, I get 12.5. This is going to be 12.5 as well. And the way I know that is because they're congruent marks. Groovy. So PR is going to be 12.5 times 12, or 12.5 plus 12.5, which would give us 25. So that's it. That's the length. And SR we could write as RS. Doesn't matter which one. Either way, they're the same. No units are given, so we're done. That wasn't too bad. Let's take a look at our next problem. Using value measure in a circle. That's what we want. All right, we're actually going to do two problems here. So we want to find what is the value of R to the nearest 10. So here we have R, which is a radius, hence why they're probably calling it R. And this is perpendicular. So if it's perpendicular, it's cutting this chord in half. So essentially what we're going to get is we're going to get a triangle here, and you guessed it, a right triangle. And this piece is only going to be 7, 3, and R. So we just got to do a little bit of Pythagorean theorem, which we got some practice on the other day, which was oh so nice. Okay. Now I just added between all three of them. That is not correct. I do need to change one of those to an equal sign. So which one should I change? That is correct. R squared is actually our hypotenuse, so this one's the one that's left by itself. So we grab our calculator, and we're going to get 7 squared, 7 squared plus 3 squared, and we get 58 equals R squared. And then we're going to do the only sensible thing, and that is to take the square root of that. And we can't actually reduce that one, so if we want to the nearest tenth, the square root of it is going to be about 7.6. And again, units are centimeters. Okay. Next, problemo. Last problem. Clear this off. Alright, in the figure, how does the auxiliary BA make the problem simpler to solve? Well, we are trying to find Y, which is correct, and if we have the auxiliary line AB in here, what we have created is a masterpiece. Now, we've created a triangle, and since that triangle that was created there has 11 on AC and 11 on CF, we know it is a right triangle. And since all radii are congruent, that EB and AB are congruent, so they're both 15. So I can solve this by doing 15 squared equals, because that's the hypotenuse, y squared plus 11 squared. And we can go ahead and solve for this. So 15 squared is 225 equals y squared plus 121. Subtract 121 from both sides, and we get 104 equals y squared. And take the square root of said number, and we can actually get that as a decimal. Now, it didn't ask us to actually solve this, but we're solving it anyway. And the square root of 104 will give us 10.2 if we round to the nearest tenth. Ah. Boom. It's good. Okay. Alright guys, thank you very much. And just want to let you know, I just want to thank my sponsors out there. So the Anaheim Ducks, just a great sponsor all my videos. Anyways, so check out the Anaheim Ducks hockey team whenever you want. So thanks, sponsors. Appreciate it. Woo! Woo! Okay, that's it. That's all I got. I'm done.